Okay, so the book told us between any 2 points, there's another point. Kind of sounds obvious, but this is the figure or the drawing that results from that definition. So let's talk about notation before we jump into these problems here. This is something AC. Okay, I'm not going to call it line AC. Why am I not going to call this line AC? Go ahead, Michael. It's got two great use of vocabulary there. It's got 2 endpoints. So here, to be line AC, what would I need on the end, on both ends? Arrows. Yeah, you'll just holler it out. So we talked about this yesterday. What about those arrows, or what do those arrows rather tell us about the line?
It's infinite.
Infinite in both directions. So, question of the day, can we measure the distance of a line?
No. Well, you can measure it infinite.
Well, so we're just talking about a line for a second. If it's got 2 arrows and it goes infinitely in both directions, is there a measurable distance for a line? No, we can't measure it. So, Michael already stole the punchline. We have to put endpoints on a line, and now we add a word after that. So, based on the book, what's it called? A line? Segment. So, I've got endpoints. I don't know why I scrolled down there. I've got endpoints A and C. So this is called segment notation. So anytime I have a segment with 2 endpoints, I need to make sure I've got that line above it, right? That line is important. It'll be on the quiz. It'll be on the test. You've got to have the correct notation in order to get in order to get these questions correct, okay? We've got line AC with point B in the middle, in between points A and C. Okay, the book called it the betweenness of points. Okay, go ahead and write this down in your notes. I'm going to go off to the side here. This is the segment addition postulate. Segment.
Wait, what is that?
We're about to write it down. Segment addition postulate. And it's just how we write out, how we set up a problem where we've got a segment with a point in the middle. So we've got line A or segment AC, and the distance, the total distance of that line segment is equal to segment AB plus segment BC. So it's very intuitive to think about the whole thing equals the part plus the part. So if I were to go back to this picture, right, the part of the segment AB plus the other part of the segment BC equals the whole thing. Okay. The segment addition postulate. We all tracking so far? So if we're going to set up this problem, we need to find the distance or the length of segment AC. We're gonna start by just writing this out, and then we're gonna substitute. Use our algebra word there. Substitute for for BC. My bad. We're gonna substitute for the values that we know. So we don't know AC, but we know AB is equal to, what is AB equal to? 4.9, and BC is equal to 5.2. Okay, we can do some napkin math here. Just do it by hand. 2 plus 9 is 11. Carry the 1. 5 plus 4 is 9. Plus the 1 is 10. And if I just write the answer like that, I'm going to get it wrong on the test. What are we missing here? Centimeters. Trying to help out your science teachers. Are units important? Absolutely. So I've got to include my units there. Okay. Any questions on example 1? Good. Going on to example 2. Being able to read these drawings is important. You're going to do this on your practice problems today. Anytime you get a line all the way across a segment, that's telling you that's the length of the whole thing. Up here, above the segment, that's telling you that's just the length between this point, and this point. Okay, so let's go ahead and write our segment addition postulate. How would we name this whole line? Or this whole segment, excuse me. What do we call it? Segment F, FG, FH. The whole thing is equal to the part plus the part. Okay, and fill in what we know. We know FH is 15. And we know FG is 9.7. And we're looking for segment GH. So on our drawing, what can we label for segment GH as an unknown? What can we use to label segment GH as an unknown? Yeah, just a variable, X. So we'll say plus GH, we said, is X. And now it's super simple algebra problem, right? Subtract 9.7 from both sides. And anybody? 5.3. Close there. Like 5.3 is equal to X. So we've got segment GH is equal to 5.3 what? Millimeters. Got to include our units. Okay. Any questions before we move on those two? Okay, say it out loud. Segment addition postulate. Okay. The part plus the part equals the whole thing. It's intuitive. It makes sense when you just look at the picture, but being able to actually write it out, we're going to get some way bigger, way more complex algebra problems out of these things. We're starting off pretty basic. Okay. Easy peasy. Okay, go ahead and write down this problem here. Example 3. Example 3. It's number 7 on the board. Go ahead and copy that down real quick. Let's read the directions together. It says find the value of x and yz if y is between x and z. Okay, and that's the important part. We're going to have to create a drawing or a figure of this segment to be able to label it and fill in the pieces that we know and don't know. So right now we Carter, you can go out in the hall, man. You don't have to stand right there. It's okay. That's okay. So we've got point y between x and z. Point y between x and z. So let's go ahead and start off with a segment here with 2 endpoints. Okay, and the way that's worded, what is it telling us the endpoints are? It says y is between x and z. So what are our endpoints? Yeah, x and z are the endpoints. Does it matter if x is on the left and z is on the right? No. Z could be on the left, x could be on the right. Doesn't matter. And then it says y is between x and z. Do we know if it's right there in the middle, or if it's off to the right, or if it's off to the left? No. It just says it's between. So you can pick any spot on that line you'd like. Draw another point and label it y. And then we've got to go back to our problem and fill in what we know and what we don't know. So this says xy equals 2x plus 1. Okay, so above the line right here between x and y, I'm going to label that part of the segment, 2x plus 1. It says yz equals 6x. And then xz equals 81. Again, like we saw in the problem above, if we've got right here the whole segment being labeled, we're going to draw a line like this underneath the whole thing with whatever the value is in the middle of that line. So right here, I'm going to draw a line underneath the whole thing, and xz is 81. So just learning how to draw these, learning how to label is pretty important. If you don't draw the segment correctly, then you're going to set the problem up wrong, and you've already gotten the problem wrong before you even do the algebra and solve for x. Does that make sense? So you've got to set the problem up correct first to even give yourself a chance to then get the correct solution. Okay? It tells us to solve for x and yz. I don't know why I did that. X and yz. So we got to find both. Okay, well, let's solve for x first. Go ahead and write out your segment addition postulate for this problem. So the whole thing, xz, equals the part plus the part. part of the segment xy plus the other part of the segment yz. And then we fill in everything we know underneath that line. So xz we know is 81. The problem told us that. We can look at the drawing. xy is 2x plus 1. And yz is 6x. Right, we got all that information from the problem. We've also got our drawing right here to give us that information as well. And now it's just a matter of, can you do the algebra to solve the problem? So we're going to subtract 1 from both sides and get 80. And then we're going to combine like terms, 2x plus 6x. So our next line is going to be 80 equals 8x. Divide both sides by 8, and you get x equals 10. So that's part 1. Part 1 is solve for x. Do we have any units, by the way, on this problem? No, so we're good. Part 1 is solve for x, and then part 2 says find yz. So we got to go back to the problem, whether we're going back here or to our drawing, right? Either way, we're good. We're going to plug in x, what we know. Oh my goodness, there we go. We're going to plug in what we know for x into yz. So x is 10, yz equals 6x. So I get 6 times 10 equals 60. Good, good, good. Before we move on, any questions on these 3 problems we've done so far, these 3 examples? Okay, very good. Let's look at these real quick. Y'all don't have to write anything in your notes. I just want to make sure that, did y'all get this definition in your vocab, congruent? Yes, no? Okay, go ahead and say that word out loud. Say congruent. Okay, and we'll just define it really simply together. Repeat after me. Say same size, same shape. In geometry, we'll just talk about if something's congruent, same size, same shape. Okay, really easy definition for you guys to be able to repeat back to me. So, are BE and CD congruent? We look at BE and CD, yes or no? Yes. They're both 3 meters, yes. Really simple. MP and NP, are they congruent? No. I've got 12 and 10, not the same size. No. And looking at WX and WZ, WX is here and WZ. How do I know there's no label on WX? How do I know what WX is?
Because there's a line.
I heard a couple interesting things. They're parallel. That's true. WX and YZ are parallel. That doesn't give me a length, though. Yeah, what are these little tick marks here? What do those represent? That, yeah, amen. Yeah, it means it's the same as YZ. That's the marking for congruent in geometry. So anytime you see that little tick mark, that's representing the word congruent. Go ahead and make a note of that in your notes. However you'd like to do that, just tell yourself next to that definition of congruent. The tick marks on a figure are going to tell us that those sides are congruent. So if the segment YZ is 9, the top of that shape is 9 feet, then this is also 9 feet. Okay, and it asks us for WX and WZ. No, they're not congruent. Perfect. Okay, we've got one more problem type to look at before we move on. Anybody have questions? Last one's distance formula. We good on this? Okay.